9.4 video. Now we're going to switch over to vectors in 3D. And we're doing vectors in 3D. Actually, it'll work like everything we did in 2D you can do in 3D. We're actually not going to do exactly everything on the first day, but if I'm talking about what is everything, it'd be like finding components, direction and magnitude, dot product, component of one along the other, projection of one onto the other, the angle between two vectors, the unit vector, all those concepts, IJK form, for example. They can all be done in 3D the same way they were done in 2D. We're not going to do every single one of them, but we'll get a sampling of some of the stuff we did in 2D. Here's kind of a quick snapshot. Vectors in 3 dimensions, so they have an ABC component instead of an AB, like 2D. Excuse me. When you're doing addition with vectors, again, you add components, or if you're multiplying, you can scale it up or scale it down by distributing that into the vector. Magnitude will now be the square root of a squared plus b squared plus c squared. So there's your third component. Dot product, there's your third component. IJK instead of IJ, so now you got your K, there's your third component. So not really like it's going to be a whole lot more complicated or difficult on the first day of doing 3D. You just got to add the extra dimension into all your work is what it amounts to. So let's do some of that work. Now this is the same exact problem I had on the 9.3 notes, the same two coordinates. So you can create a vector or you can find the vector's components by going from P to Q. When we do that, remember we subtract actually backwards, so we go Q minus P. If you do negative 4 minus 2, the A component would be negative 2. Negative 3 minus 4, negative 7. Negative 6 minus 5, negative 11. And there's my three components. IJK format is, just simply rewrite it. So when you're doing a problem, I know there's going to be a problem in WebAssign where it asks you to do this and doesn't quite, it sounds like it asks you to do something else, but basically it's just a rewrite. Just rewrite the components, IJK form. And then magnitude, if you think about the problem in 9.3, the 9.3 notes or video, magnitude, of course, when you're talking about from one point to the other is actually length. It can be weight, it can be force, these kind of things, but in this case, it's just length. So we already did that problem, right? Square root of a squared plus b squared plus c squared, square root of 174, or 13.2. So magnitude is length when you're talking about point to point. So again, it really repetitious from 2D, pretty simple to do if you feel like you got the 2D concepts down. Let's do some of the other stuff that goes along with it. This one's a little bit of a twist in the problem. So if I give you the vector and I give you the initial point, could you find the terminal point? And if you think about it, another way to write your components of your vector would be, if I was doing x minus x, y minus y, z minus z, is to say, well, I don't know one of the two pieces of each of these components, which is like what's the terminal point, right? So if I consider x, y, z to be my terminal point, then this would be how I would be finding the component. P minus q, p minus q, p minus q. Well, if that's the case, and knowing what the components actually are, I can set up a bunch of little mini equations. Basically say, well, here's the A component, here's the B component, here's the C component, here's how I would find it. And then a little simple algebra, and you got this. And again, if you think about this, it makes, I think, perfect sense. So basically, you're finding like the missing coordinate, right? Knowing the components. So just a little twist in the problem, but I don't think anything that you guys will have any trouble with. Okay, so getting out of components and talking about some of the other stuff. So here I've got some of the writing down just to save a little bit of time and some of the work. And so as you guys go through, I'll talk through what's going on here. But I like always looking at vectors when I'm talking about vectors, right? Because if you just talk about it as do the dot product, you just do like the formula, you don't see anything, I think you just start looking, it's a bunch of formulas, like kind of meaningless formulas, right? So it's always good to put a visual to what you're talking about. So here's the two vectors plotted. If you actually did the u vector as 3, and I'm going to go ahead and do it so we practice that. I think I've got it here. Yeah, there we go. There's 3, negative 2, and then negative 4. And there's my vector. Okay. If I'm doing the v vector, negative 2, I'm going to have to move it here for a second. Negative 2, negative 4, and then 2. Now those ones that are the z components, I'm just estimating those because I don't have tick marks to really work off of, and I'm out there in 3D space anyway. So I'm just estimating those as best I can, and there's the v vector. So are they dot product to start? Dot product being negative. Dot products can be negative. Are they perpendicular? No, because dot product isn't 0, and maybe over here I can tell that they're not anyway, but you guys won't be sketching this when you're answering the question. So dot product was 0, I'd answer yes, but it's not. It's a no question. And then angle between. Now as I look at it, the angle between, I'll try to sketch that for you guys quick here. Talking about what's the angle between the vectors right here. I feel like even though it's 3D, that's probably not, that's probably bigger than 90, I should say. And when I go do the calculation, here's the work. So dot product, -6, magnitude of u, magnitude of v, inverse cosine of all that, and I'm getting 103. And 103 would be the angle between these two vectors. So again, I think when you get the visual going on, at least that's nice to say, like, here's what I'm finding, here's what I would see, right? So there's, some of the things we've done, right? Dot product, perpendicular, angle between. Again, we're not doing everything. We're going to leave out a few things like projection and component and that kind of stuff, but just kind of for the first day, a little sample of some of the same stuff we did in 2D. And that's really it. So that'll wrap up our notes for today, and hopefully you guys can follow that pretty well, and I'll see you tomorrow.